In this video, we will be talking about systems of inequalities. So we've dealt with solving systems of equations where we either graph them, substitution, or elimination. We use one of those algebraic methods. When we were solving systems of equations, we were looking for the intersection point. All right. When I'm dealing with systems of inequalities, I'll be looking for the intersecting region. All right. Because if you remember from last video, when I'm graphing inequalities in two different variables, I have a boundary line and then I shade above or below. It's the same exact thing here, but when we shade, there's going to be an overlapping region where these shadings occur. All right, that's going to be the solution region for this system. So let's get into what this looks like. All right, so we got this system of inequalities. First one is y is greater than negative 2x minus 5. So I'm going to start by doing the boundary line. I'm going to start at negative 5, and my slope is negative 2. So I'm going to go down 2 to the right 1, down 2 to the right 1, or up 2 to the left 1, up 2 to the left 1, so on and so forth. Okay, just going to give a couple more points, and then I'm going to connect the dots. Now, we've got this boundary line. Is it going to be a solid line or a dashed line? So since it's y is greater than negative 2x minus 5, I don't have equality, so it's going to be a dashed line through all these. Okay, so there is my boundary line. Since it's y is greater than negative 2x minus 5, I'm going to shade above. Okay, so I'm just putting these little arrows to remind me that this inequality I'm going to shade above. Now I'm not going to shade yet, okay, because I've got another inequality I've got to graph. So this is our first one. Now we got to do our second one. We got y is less than or equal to x plus 3. So to graph this, I'm going to start at 3. I'm going to go, my slope is 1, so up 1 over 1, up 1 over 1, or down 1 to the left 1, so on and so forth. All right? Now, it's less than or equal to, so this boundary line is going to be solid. So I'm going to draw a solid line through here. Put my arrows, and it's less than or equal to. So I'm going to shade below this line. Okay, so now what is the solution region for this system? It's where my shadings overlap. And notice that those shadings overlap in this whole region. Okay, this is where I shade above the blue line, but I shade below the orange line. Okay, so this is my solution region. So now, determine which of the following test points are solutions. It needs to satisfy both inequalities. Just like the solution back in systems of equations, when I plugged in for x and I plugged in for y, it needed to work for both equations. Same thing here. When I plug in a point, it needs to work for both inequalities. So I can look at the graph. I can say, okay, negative 1, negative 3. Negative 1, negative 1, 2, 3. It's this point right here. All right, it works for the orange line because it's below the orange line, but it doesn't work for the blue line because I do not have equality on the blue line. So no, and the reason I could check that, if I plug in negative 3 for y and negative 1 for x, I get negative 3 is bigger than negative 3, which is not true. Okay, it equals negative 3, but I don't have equality there. All right. What about 7, 5? Get another 7, 5. 7, 1, 2 is right here. We can clearly see that that is in the solution region, so it's going to work for both of these inequalities. You can also check algebraically. Plug in 5 for y, plug in 7 for x. So I'll get 5 is bigger than negative 14 minus 5, which is negative 19. That's true. Then I can check it in the second inequality. So plug in 5 for y, less than or equal to 7 plus 3. So 5 is less than or equal to 10. That works as well. So I can check it by looking at my graph. I can also check it by just plugging in to both inequalities and making sure it works. All right, let's try another one. So we got 2x plus 3y is less than 6. First thing I need to do here is get this into slope-intercept form. So I'm going to subtract 2x from both sides. So I'll get 3y is less than negative 2x plus 6. I'm subtracting 2x from both sides. And then I'm dividing everything by 3. So I get y is less than negative 2/3 x plus 2. All right, so now that it's in slope-intercept form, I can start at my y-intercept of 2, and then I can apply the slope. I can go down 2 to the right 3, down 2 to the right 3, down 2 to the right 3, or I can go up 2 to the left 3, up 2 to the left 3. So now I got those points. My boundary line is dashed because I do not have equality here. So I got a dashed line. And since y is less than, I shade below. So I'm just going to put these arrows for right now because that way I know that I'm going to shade below once I have my overlapping region. Okay? Next up is y is greater than or equal to negative 2/3 x plus 4. So this is already in slope-intercept form. I'm going to start at 4, and I'm going to go down 2 to the right 3, down 2 to the right 3, so on and so forth. Just getting a couple more points. All right, and this is a solid line because I have equality. And this is y is greater than or equal to, so I'm going to shade above. All right, well, here's the issue. If I shade above for the purple line, I get this region. If I shade below for the red line, I get that region. Is there any overlapping region? No. Okay, so there's no overlapping region. So we have two parallel lines here, and their shading regions are going in opposite directions. There's no overlap, so this has no solution. There's no solution to this system because there's no overlapping region between both of those inequalities when I graph them. Okay? That's the main thing to look for. Parallel lines, you can have a solution for those. You could have a solution region. Like if it was the region in between them, that would be a solution region. Okay, so don't think if you have parallel lines it's no solution. You got to look for where the overlapping region is occurring. And if there's no overlapping region, that's when you have no solution. Okay? One more. Let's graph these. First off, we've got y is less than or equal to 3. So that is going to be the horizontal line through 3. It's solid because I have equality. That's not the best. So it's going to be a solid line through 3. And y is less than or equal to, so I'm going to shade below. Next up, we got to get this one into slope-intercept form. Negative 2y is greater than 6x plus 8. When I divide everything by negative 2, all right, I divided by a negative, so I need to remember to put a different color here. Flip the inequality symbol. So then 6x divided by negative 2, that's negative 3x. 8 divided by negative 2 is minus 4. All right, so I'm going to start here at negative 4. I'm going to go down 3 to the right one, or up 3 to the left one. Get a couple more points. And this is going to be a dashed line. I do not have equality here. Put my arrows on. It's less than, so I'm going to shade below this boundary line. And then our last one is x is less than negative 2. So that's going to be the vertical line through -2. And it's going to be dashed because I do not have equality. And it's x is less than, so I'm going to shade to the left because x is going to be needing to get smaller here. All right, so we got a lot of different arrows happening here. But if you notice, our overlapping region is below this line, below the red line, and to the right of the purple line. Okay, so right here is my solution region, and it's going to keep going on for infinity in this area. Okay, this is my solution region. So anything on a solid line we would include, but if it's on the dashed line, we would not include. That's not part of the solution set. Those dashed lines are just setting the boundary here. Okay, so when we graph all three of those, it's really important. Don't just start shading everywhere. Draw those little arrows and then see where that overlapping region is. All right, so all we're doing is taking the previous lesson where we graphed inequalities on the coordinate plane, and we're just doing 2 or 3 of them at the same time. We're graphing them on the same coordinate plane, and we're seeing where that overlapping region occurs. All right, make sure to tune into the next video where we do a couple other practice problems.